Tail strike. What can we do to avoid getting into a tail strike situation? Well, as simple as it sounds, a tail strike can only occur if the pitch attitude is too great when you're close to the ground. It's basic geometry and airspeed. The clearance between the tail and the ground is directly related to pitch attitude. Now let's use the computer stop action so we can see what happens in more detail. You'll notice that for a normal takeoff, the minimum tail to ground clearance occurs right after liftoff. The evidence shows that one of the most important factors in avoiding a tail strike is the pilot's ability to rotate properly and to achieve the correct pitch attitude at liftoff. If you're at struts extended with the main wheels on the runway, a tail strike occurs at about 12.5 degrees of pitch attitude. The flight director pitch bar is positioned above the airplane symbol during the takeoff roll. It's not intended to be used until after liftoff. Takeoffs using flaps 20 offers the largest amount of tail clearance of any of the takeoff flaps. There are, of course, other factors involved besides just flap settings. Takeoff tail clearance is strongly affected by airplane speed at rotation and pitch rate during rotation. Even though Flaps 1 is certified, our canvassing of operators shows that it is rarely used. So let's start with Flaps 5. At Flaps 5, and at the recommended takeoff speed schedule, with the struts fully extended, you'll have 33 inches, or almost 3 feet of clearance. At Flaps 15, and at the recommended takeoff speed schedule, with the struts fully extended, you'll have just over 3 feet, or almost 1 meter of clearance. At Flaps 20, the aft body clearance is 4 feet. Flaps 20 gives you over 1 foot more tail clearance than Flaps 15. Let's break down the takeoff into areas that are important from a tail strike perspective. First of all, set and confirm the correct stabilizer trim setting for takeoff after the load adjustments are complete. Improper nose-up trim may produce lighter than normal stick forces and result in an early or rapid rotation. Use the correct airspeed to begin the takeoff rotation. Reduced thrust or derated operations require higher airspeeds, accounting for such things as gross weight, flap settings, or engine derate. For derated operations, use the appropriate performance chart. For reduced thrust, use the airspeed corresponding to the assumed temperature selected for takeoff. Do not start rotation before VR. Rotation before VR results in reaching a greater than normal pitch attitude prior to liftoff. During rotation, speed, attitude, and altitude change rapidly. Pitch attitude is a primary control reference. A smooth, continuous rotation of 2.5 to 3 degrees per second will achieve proper liftoff attitude, which will give sufficient tail clearance. The airplane may develop an excessive nose-up movement very quickly if the pilot makes an abrupt control column movement to what he thinks is the correct position. There may not be enough time to make corrections once an excessive pitch rate is begun. The goal is to achieve the correct target liftoff attitude of 8.5 to 10 degrees in 3 to 4 seconds. Continue the smooth rotation until approximately the target climb-out attitude. Do not aggressively achieve V2 plus 15. What are some actions that you want to avoid? There are several factors that could contribute to a tail strike on takeoff. Let's list them. Incorrect stabilizer settings. Incorrect VR. Early rotation. Excessive pitch rate and improper use of flight director commands prior to liftoff. When there is no cockpit indication of pitch rate, you can count the seconds. 1001, 1002, 1003, until the rate becomes a natural process for you. Let's look at an actual takeoff tail strike incident. In this incident, the crew was overly concerned about noise abatement. The airplane had a gross weight of approximately 200,000 pounds. Runway was at sea level. VR was 132 knots. Takeoff acceleration was normal. The pilot initiated rotation at 118 knots, 14 knots before VR. Liftoff occurred at an attitude of about 9 degrees. The airplane continued to rotate to about 15 degrees within about 4 seconds from the start of rotation. At that point, tail strike occurred. What went wrong? Let's take a closer look. Two events combined to cause this tail strike. The first event was that the rotation of the airplane was initiated 14 knots before the recommended VR of 132 knots. By starting rotation before VR, the airplane was not developing enough lift to become airborne. The second mistake was that the pilot increased pitch attitude rapidly. A tail strike occurred. So we've seen the factors that can cause tail strikes on normal takeoffs. Let's quickly review the recommended procedures for avoiding a tail strike on takeoff. Consider using flaps 20 when possible to maximize tail clearance. Set and use correct rotation speed. Rotate at a smooth and continuous rate of approximately 2.5 to 3 degrees per second. Liftoff should occur at a pitch attitude of about 8.5 to 10 degrees. Continue the smooth rotation until target climb-out attitude is achieved. Now, let's talk about landings. Here's an example of a runway from an earlier model airplane. This is the runway from inside the 757. The 757's increased downward vision is especially helpful for low visibility approaches. Compared to other airplanes, more of the runway remains in view, so a pilot's visual cues of a high pitch attitude can be different in a 757. The clearance between the tail and the ground is directly related to pitch attitude. With the struts compressed, tail strikes occur at about 10.5 degrees of pitch attitude. How can you plan your landing so you can reduce tail strike risk? We'll look at flap settings, final approach speeds, and typical touchdown attitudes. All proper landings have one thing in common: a stabilized approach. The airplane should be stabilized on flight path, on speed, and in trim by 500 feet AGL. The stabilized approach leads to a more consistent flare point, touchdown attitude, and touchdown speed. Flap settings influence touchdown attitude and, of course, tail clearance with the main gear struts compressed. Let's take a look at some comparisons. You can see that at flaps 25 with a touchdown attitude of 7.7 degrees, there is 29 inches, almost 2.5 feet of tail clearance. That's about 3/4 of a meter. At flaps 30 with a touchdown attitude of 6.3 degrees, there's 39 inches, just over 3 feet, or about 1 meter of tail clearance. Okay, let's use some computer stop action again to look at flare and touchdown techniques that relate to tail strikes. The actual heights and pitch attitude adjustments will vary a bit depending on your sink rate, winds, and other factors. Let me show you a normal landing using auto brakes. Approaching flare, speed should be bled off to VREF +5 plus any gust correction. Start the flare at about 20 to 30 feet above the runway. Approximately 2 degrees of pitch attitude change will be the result. Reduce thrust smoothly at the beginning of flare to achieve idle at touchdown. Smoothly increase pitch to slow the rate of descent to an acceptable level. A speed bleed off during the flare of approximately 5 knots and a touchdown attitude of 4 to 6 degrees is normal. main gear touchdown occurs simultaneously with thrust reaching idle. Touchdown should occur at approximately VREF. Allow the airplane to fly onto the runway without ever stopping the rate of descent. From a tail strike perspective, pitch attitude control after touchdown is very important. After main gear touchdown, fly the nose wheel down smoothly onto the runway. Holding the nose up for aerodynamic braking is not an effective way to slow the airplane. Remember, a tail strike will occur at approximately 10.5 degrees of pitch with the main gear struts compressed. Since a proper flare normally gives you a touchdown pitch attitude of between 4 to 6 degrees, and a tail strike occurs at 10.5 degrees, don't allow the pitch attitude to continue to increase after touchdown. All landing tail strikes analyzed by Boeing to date have occurred with increasing pitch attitude between 2.5 and 5 seconds after main gear touchdown. Let's look at actual situations and see what actions caused a landing tail strike. In this incident, there are two factors to watch: elevator position and pitch attitude. Approach and landing speeds were within the normal range. At touchdown, the pilot increased nose-up elevator, causing the pitch attitude to increase further and the airplane to strike the tail 3.2 seconds after touchdown. In this next incident, the factors of airspeed, pitch attitude, and stab trim are very important. At 50 feet, the airplane was at VREF plus 5. The pilot flared the airplane using 4.2 units of stabilizer trim and a relatively small amount of elevator. The landing occurred at VREF minus 8. The use of stabilizer trim to flare the airplane caused the pitch-up attitude to increase after touchdown. This resulted in a tail strike 3.8 seconds after touchdown. In this incident, the factors of airspeed, pitch attitude, and elevator position are important from a tail strike perspective. Flare was initiated at about 50 feet, bleeding off 16 knots of speed. Touchdown occurred at VREF minus 16 and at an above normal pitch attitude. The elevator used to flare was held in after touchdown. This caused the pitch attitude to increase, and a tail strike occurred 2.6 seconds after touchdown. Analyzing this information and other tail strike data, we can recommend some methods that pilots can use to avoid tail strikes during a landing. Here's a list. Do not allow airspeed to decrease below VREF before touchdown. Be in trim at the start of flare. Do not use stabilizer trim during landing flare. This can cause the airplane to continue to pitch up after touchdown. Do not hold the airplane off in attempt to make an extremely smooth landing. If your normal pitch attitude at touchdown is between 4 and 6 degrees, and a tail strike will occur at 10.5 degrees, do not allow pitch attitude to increase after touchdown. Remember, aerodynamic braking is not an effective method. It is important to fly the nose gear onto the runway immediately after main gear touchdown. So, to sum it all up, the airplane can be very forgiving. Plan ahead with tail clearance in mind. Use proper technique. Continue to fly the airplane through takeoff and landing. If you plan ahead and use the recommended procedures, tail strikes will not become a reality for you.